And thank you so much for the introduction. Here's my talk, What Makes Software Green? So as introduced, my name is Sarah Hsu. I'm a site reliability engineer working for Goldman Sachs. I'm originally from Taiwan, but I've been living in the UK for about 15 years now. I sort of wear two hats. I'm an SRE for GS. I'm also the point of contact for GS with the Green Software Foundation. And I'm also chairing the Principles Project. I'm here today because I want to share with you my aha moment when I first discovered green software a couple of years ago. Specifically, how simple and powerful the principles of green software are and how connected they are already with the best practices we're doing in many other areas, such as performance, reliability, or cost. And I hope that by the end of this talk, you also have your aha moment with green software. So the agenda for today, well, this introduction, and we will move on to principle of green software, specifically what the three activities that make software green. And if we have time, I really would like to talk to you about the Green Software Foundation, who we are, how we work, and some of the exciting projects that we have got going on. So, what makes software green? We define green software as software that emits the least amount of greenhouse gases, aka carbon, possible. There are three activities that can make that happen. Firstly, we can be efficient with energy. Secondly, we can be efficient with hardware. And finally, we can make our software carbon aware. Those activities make software green because they can help us reduce the carbon emissions of our software. And we can sort of group energy efficiency and hardware efficiency together because both categories can be considered as a proxy for carbon. And being efficient with one of them, or both of them, will make us being more efficient with carbon. So why is hardware a proxy for carbon? Every object we come across in our daily lives emits carbon during the creation and destruction of the said object. That includes this laptop that's playing the presentation, the servers in data centers, all the materials that was used to build this space. We call this the embodied carbon of an object. This is a really, really important concept to bear in mind. It's because when we are calculating the total carbon emissions of our software, there's more to it than just the carbon from its electricity consumption. We need to make sure we also include the embodied carbon of hardware. There are two broad categories for achieving hardware efficiency. For applications in end-user devices, we can think of ways to extend the lifespan of hardware. For applications in the cloud, we can look into increasing the utilization of hardware. As you can see on the slide, for most end-user devices, the embodied carbon is much, much more significant than the lifetime emission from its electricity consumption. So this strategy of extending the lifespan of hardware is probably of most interest to people building softwares in the end-user space. When our application is lagging our mobile phone, almost everyone, including me, first thought is like, should we get a new upgrade? So one thing software engineers can do in this space is to make sure that the applications they're building also work on older models. Let's do a quick illustration. If our device has 1,000 kilograms of embodied carbon and the expected lifespan is just 2 years, then that's 500 kilograms of embodied carbon per year. But if you can extend the expected lifespan by 1 year to 3 years, then that's about 333 kilograms per year. Let's look at other examples. So we have 5 servers, each running at 20% utilization. The total embodied carbon will be 5,000 kilograms. But can we just have one server running at 100% utilization and embodied carbon will only be 1,000 kilograms? Although no one should ever run anything at 100% utilization. This is just an example. But this is a great example to tell us that even though most on-premises data centers are still struggling with fully utilizing their servers, so for any applications in the cloud, that being private cloud or public cloud, we can think of ways to increase the utilization of hardware that make us being more efficient with embodied carbon. And that means we're achieving hardware efficiency, and then that means we're being efficient with carbon. It's normally misunderstood that by choosing to host your application in public cloud. That makes your application straight away more sustainable. That's a misconception. The choice of a public cloud gives you the capability to be more sustainable only if you design your application in a suitable way for the chosen public cloud. So going back to what we previously mentioned, our goal is to reduce carbon emissions of our software. And we can achieve this by making our software either carbon efficient or carbon aware. And one way to achieve carbon efficiency in software is to be efficient with embodied carbon, because we can think of hardware as a proxy for carbon. We can also think of electricity as a proxy for carbon. To this day, electricity production is still the biggest single emitter of carbon. That's because most of electricity is still produced through the burning of fossil fuels. So if our goal is to be carbon efficient, we should also be energy efficient. The data center industry uses this concept called power usage effectiveness. It was developed by Green Grid in 2006. It basically tells us how much energy coming in from the grid goes to the servers doing actually something useful compared to going to other overhead activities, such as cooling. So if our data center's PUE is 1, what that means is for every kilowatt hour of electricity comes in, it goes to the servers. But when PUE increases to 2, that means for every 2 kilowatt hour of energy comes in, one goes to do something useful in our server, so the other one will have to go to overhead activities supporting the data center. Another way we can think of PUE is as a multiplier of an application's energy consumption. It's a way for us to conceptualize how much energy is needed to support our application in a particular data center. So for example, if our application consumes 10 kilowatt hours, and then the PUE of the data center is 1.5, what that means is we actually need 15 kilowatt hours from the electricity grid, where 10 kilowatt hours will go to the servers, and 5 will go to the overhead activities. So the closer the PUE is to 1, the better. PUE of 1 is the optimal value, but that's not possible. So achieving closer to PUE of 1 is what we need. Similar to PUE, there's a concept called energy proportionality. Energy proportionality is about the relationship between electricity consumed by the hardware and the rate at which useful work is done. And we can sort of think of rate at which useful work is done as how busy something is, its utilization. If you were like me, you might have assumed that the relationship between these two quantities were linear and the line goes through 0. But that's far from the case. When computers are not doing anything, they're sitting idle on our desk, they still consume electricity. We call this the static power draw of hardware. And they can be quite significant. As you can see on the graph, when the servers get more utilized, it gets better and better at converting electricity to practical, useful computing operations. So this concept of energy proportionality further emphasizes how the usage of electricity is so tightly coupled with the carbon emissions of our software. So to recap, very similar to hardware, we can think of electricity as a proxy for carbon. So if our goal is to be carbon efficient, our goal should also be energy efficient. And the principle of green software encourages us just to do that. It wants us to build energy efficient applications. And energy efficient applications are applications that uses the least amount of energy wherever, whenever possible. That includes energy from the grid, all the way to the servers, and then to the servers, and then to the data centers, and then to the servers, but not to the overhead operations, and finally to the end user. Most of us probably think electricity is clean, but that's far from the case, because when we plug something in the wall socket, our hands don't get dirty, there's no smell, and normally we don't even get to choose how electricity is produced. We get what's given to us by our energy providers. So we have this concept called carbon intensity. We use this concept to measure how clean and dirty electricity is. The carbon intensity of electricity measures how much carbon emitted per kilowatt hour of electricity consumed. Carbon intensity changes by location because each region has different access to different types of renewable sources. For example, in Taiwan or the UK, we have much more access to like wind farms. Carbon intensity also changes over time because we do not get to control the weather, as everyone knows. So sun might stop shining, wind might stop blowing, then our carbon intensity may increase because we need to start burning fossil fuels to get the energy. So doing more in your software when carbon intensity is low and doing less when carbon intensity is high is what we call carbon-aware computing. There's a huge traction for carbon-aware computing at the moment, not just driven by the Green Software Foundation, but by various cloud providers and their consumers. A good and straightforward example is, can you move your batch job to a time when energy is clean? How about your workload? Can you move it to a region when the carbon intensity of electricity is low? But what about demand? Supply has to always meet demand, right? As said, demand shifting is about moving workload to a region or a time when carbon intensity is low. Demand shaping is a similar strategy, but instead of moving the demand to a different region or time, we are shaping the computation to match the existing clean power supply. You probably have already come across something similar to this. Imagine like Google Meet or Zoom. When you're making a video calls and carbon intensity is high, they can prioritize the audio so people can still have a conversation, but reduce the quality of the visual. So basically, they are matching the demand with the existing electricity supply. This is probably my favorite slide of all time. So if anyone wants a copy so they can hang up in their bedroom, please let me know. So to recap, we define green software as software that emits least amount of greenhouse gases, aka carbon possible. We can either make our software carbon aware or carbon efficient. And there are two ways to achieve carbon efficiency in software. We can choose to be efficient with hardware or efficient with electricity, because we can think both of them as proxies for carbon. So why is sustainability in tech such a hot topic right now? It's not just because the cloud has a bigger carbon footprint than the airline industry, and because software is just only going to get more integrated with our society, but also how difficult it is to implement the net zero strategy across all industry, not just tech. Net zero strategies are incredibly difficult to achieve because it demands 90% of carbon reduction through elimination and not through offsets. We will talk about this in the next slide. This slide sort of explains the ways we can reduce carbon emission. Basically, we have two paths. We can choose to reduce emission through offsets, or we can choose to reduce emission through abatement or elimination. Let me give you an analogy. If you're driving a car from A to B, and you choose the compensation strategy to eliminate your emission, you basically have to pay someone else not to drive from A to B, so you get to drive. And if you choose the neutralization strategy to reduce your emission, that means you have to find projects or method to remove the carbon you emitted into the atmosphere. Finally, if you choose the elimination strategy, you don't even get to drive. Nobody gets to drive because we can't emit any carbon into the atmosphere whatsoever. So I hope this analogy reiterates how difficult achieving a net zero strategy is, because net zero strategy demands 90% of carbon reduction through elimination and nothing else. So here are all the principles of a green software. They further explain the three activities that make software green. I do encourage you to go check them out, and because those principles form a core set of competencies. By understanding them, you can make decisions that have a meaningful impact on the carbon pollution of your applications. We start off revising the original principles, which were written in 2019, earlier this year, in January. And I'm really happy to share we actually have finished the latest iteration, and it will be published in COP27. We have also been working with the Linux Foundation to turn the principle of green software into a learning material. So why are those milestones important to you or your companies? As most of us know, the most significant bottleneck to adopting green software practices is the lack of knowledge. We as a community didn't have standard terms, we don't have a shared knowledge to carry out sufficient discussion. we desperately needed a unified entry point for anyone in tech to kickstart their green software journey. And as more organizations look into high green software talent, this learning material can serve as a method for companies to evaluate the people they want to hire that meet a minimum and consistent understanding of green software. And since the revision of the principles were completed, we have been expanding the project scope to call something practices and patterns. So principles, patterns, and practices. As we know, principles are core set of competency for anyone in tech to know so they can define, build, and run green software. Basically, it's a set of guidelines on how to do things green. But what about how do you actually apply those principles? While actionable advice people can straight apply to their applications. I ask every single time any one of us brings up principle of green software. So that's where patterns come in. Patterns is an online open source database. It's a catalog of all the best practice for different domains, including cloud, web, AI, programming languages, but we want to apply those best practices in a vendor-agnostic way. So for example, right now, our patterns catalog will include loads of actionable advice for you to achieve hardware efficiency in many different domains. So we have talked about what green software is, why you and your company should care about green software beyond the obvious global warming strategy, and all the important climate benefits of applying green software practices. I'm probably a great example of this particular study. 64% of millennials say their job is more fulfilling when they are I got it wrong. 64% of millennials consider a company's social and environmental commitments when deciding where they want to work. And 88% of them said their job is more fulfilling when they are provided the opportunity to make a positive impact on environmental and social issues. And I have no doubt those figures will be much, much higher for Gen Z. So before I wrap up, I really want to talk to you about the Green Software Foundation, who we are, and some of the exciting projects that we have got going on. So Green Software Foundation is a non-profit foundation underneath the Linux Foundation umbrella. We are separate legal entities, but we get a lot of help, direction, predefined processes from the Linux Foundation. Our mission is to change the way we build software across global tech industry so there are no harmful environmental effects. The Green Software Foundation was formed in May 2021 with 8 member organizations, including Goldman Sachs. As of today, October 2022, we have over 38 member organizations, including nonprofits, for-profits, and academia. And one of the really exciting initiatives we've got going on right now is our first ever hackathon, Carbon Hack 2022. The objective of this hackathon is to build the best carbon-aware solution using the Foundation's very own carbon-aware SDK. What is carbon-aware computing again? Carbon-aware computing is doing more in your software when carbon intensity is low, but doing less when carbon intensity is high. Registration for the hackathon doesn't actually close till the submission date, which is November 4th. So do sign up. There is still a chance, and you might be one of the lucky winners to take home the 40K cash prize. Right, so I hope you found this talk useful and you have enough to kickstart your own green software journey. And you have also realized the close connection between the principle of green software and the best practices we're already doing in many, many other areas, such as reliability, operation, performance, or cost. And if you have any questions, please do ask me. I'm going to stick around for half of the day, and we might have a Q&A. Yes, okay, good.
We have a Q&A now. So first, thank you for this great presentation. Yeah. We have some time for questions. Who wants to jump in? Yeah, we have someone here. And
it's really bright, so it's quite hard to see. I'm going to move this way a little bit.
Yeah. Hey, thanks, Sarah, for the talk. It's obviously very topical at the moment with the FCA just talking about greenwashing as well, and kind of being a bit stricter on what companies say around that, around being green. Do you think regulators will help excel that journey towards green, or do you think it might hinder it or put off people because there's maybe more regulations? What are you thinking?
I do have an opinion. But I always tell people if carbon tax become a thing, it would be similar to GDPR, where everyone will scramble to make the requirement, but which is a great thing because that means every company will then have to revisit how they set those climate commitments, because you hear loads of different jargons like carbon neutral, carbon positive, climate positive. A lot of those jargons doesn't actually mean anything. And we really, really need something called a net zero strategies because we need 90% of the reduction through elimination. So global warming, hopefully, will stabilize to 1.5 degrees Celsius. So I think it will help, but we are still a bit far away. And then it all depends on different legislation across the world as well.
So instead of a general data protection regulation, it will be green data protection regulation, right? So GDPR is back. We have a new question here.
Hello, Sarah. It was a great presentation. So my question was like, as we are moving more and more towards decentralization and decentralized finance, DeFi, what is your opinion on like mining and cryptocurrencies? And as they consume a lot of computing powers, but we are moving in a world towards that. So how do we, mitigate and manage that in terms of having a carbon footprint?
Thank you.
I think I got that question. Your question was about how do we think about some of those really computational heavy
like
things.
decentralization, like data mining, like Bitcoin and cryptocurrencies. And as we are moving towards that, but how do we manage like a carbon footprint?
Measure. I think we can't do anything without measuring. I actually didn't have enough time to talk about this, but basically, as most of you know, that greenhouse gas protocol is the ways that people measure the carbon pollution that a company produces. The Green Software Foundation actually has a different formula that instead of asking people to bracket where their electricity falls to, because it can be quite complicated, especially if you're an open source provider. How do you know where people run their software? Do you even have the ability to track where software is running? So there is this SCI called the Software Carbon Intensity Specification. It's a way for people to measure software. And measurement is just the first part of the story. I guess because I'm SRE, it's always about striking the right balance, right? So you need to find the right balance that you're still pushing the technology forward, but you are also being conscious of like your carbon footprint. And I guess like the story of climate change is about waste. How do you make sure you're not wasting things? Can you make sure you're mining data in the most sustainable way that's not wasting a lot of things? Are you turning things off? Are you being the most efficient with energy? So I think, long story short, you just need to find the right balance. And we're always going to emit carbon. It's just, even breathing, we emit carbon, so.
Let's continue to breathe a little bit. we have one question here. Say my morning sport. Rugby.
Hey there. You talked about being smarter with how we use compute power based on like the energy mix when we have renewables or we have more fossil fuel usage. Is there streams of data available on those sorts of things for companies to consume easily to be able to make those sort of decisions?
Yes, so Carbon Hack is actually working with a company, a non-profit called What Time. And they call What Time because it's what time you want to run your compute. Anyway, so they actually provide carbon intensity of electricity across the world. There are I think Google works with Electricity Map, which is another company that provides carbon intensity. And in the UK, there is a free one that's between National Grid and someone. I think just called National Grid Carbon Intensity. So these are the three websites where you can find useful data.
We have time for one more question. I have a question about like Jevons paradox or rebound effect. You know, Jevons paradox is when, as a technology becomes more a commodity, so a decrease in price, we use more of it, right? So, or sometimes called the rebound effect. Every time we save something, actually we use that savings to reinvest somewhere else. So we don't reduce the consumption of everything, right? And energy in particular. So my question is like on a cultural side, how the Green Software Foundation, and maybe you what you're doing at Goldman Sachs and everything, but how we can tell company, the savings you made, keep them as savings, right? Should not reinvest in something else like to really reduce and not just do more with the same. Does it make sense?
Sort of, you're saying like, how do we actually convince companies to implement green software practices?
Yes, but to implement, to reduce, and just to reduce, and not just do more with the same, right?
For the same,
It's a tough question. And I
Yeah.
don't think there is an answer today, but if you can give you some hints, right, about where to find.
yeah, okay. How do we convince companies? I think it's all about like, the really like, people, there are people out there who, it's their jobs to demise products, right? It's not the most fun jobs, but they have to demise products. So that means we are actually telling companies to do this because there's actually a much better product out there. And I think, especially in banking right now, the technology investment has shoot up drastically in past 10 years. Even in GS, we have a lot of legacy in-house built product that we are looking to demise, just because why don't we want our engineers to work on things that's old and doesn't really work, and they can work on something interesting if we just choose to move to a product that's more interesting, like in the cloud provider. So I think it's all about like striking the right balance again, and to make sure that you tell people applying green software practices is not just about reducing. There's so many added benefits. And it's actually been quite an interesting trend. For the past year, a lot of people will say, oh, sustainability should be like a separate pillar of consideration. I think like Amazon, Amazon Azure, they both have a different pillar of consideration for sustainability. But that is actually asking our already really stretched software engineering teams to add another principles they have to think about. So right now, a lot of companies, what they do is they will start to map out the added benefits. So for example, making your computation more energy efficient and using less hardware, you already have those added benefits, right? So I think that's another thing we can think about. So it's not just reducing, there's added benefits to reduce, because you get cost, you get people happier, you use less hardware. So there's like, all come back together, if that makes sense.
At the end, yes, it makes sense at the end, right? So good. Yeah, perfect. Thank you very much. Oh, no, we have a last one. We have a last one here. No, of course.
You just spoke about the added benefits. So I had a quick look on the website while you were talking. And one of the things was like reducing network traffic. And it's like, there's an added benefit of that and just like debugging. Has that been ever like sort of spoken about, like actual sort of software benefits to going greener? I don't know if that's a topic on the website or not. So
your question is whether we talk about the actual coding benefits of green software practice, such as reducing the network traffic. Yeah, so we actually do. So I guess like principles is just like a high level of how you should do things green, and a few things you should consider, right? So we now have something called the patterns, and patterns is really about how do you actually apply those principles into a specific domain. For example, we now have like patterns to advise people, like you should cache your static data. You shouldn't have to like send data over every single time, right? But then that's like, you have to consider how often that data needs to be set. And for example, like storage, you should always have retention policies, right? So I think now we do realize principles is all good and well, but like how do you actually do things is what we are missing. So the patterns database, if I can just go back to the page, actually includes loads of actionable advice. And if anyone here would like to become an SME or just create a pull request to add best practices to a patterns database, please do. And we will eventually evolve patterns into practices, because patterns are vendor agnostic way of doing something well, and practice is the vendor specific ways of doing something well.